Okay, let's get started. In the last class, we discussed about end-to-end build and deployment workflow. We also wrote a simple Java program, and then we compiled Java program manually, and then you know how the binary code class file looks like, right? And then we understood the importance of Maven, right? Why we got it as a build tool and so on. Today, let me explain something called Java build process. See this? So we know one thing, that when developers write Java code, say a.java, for example, we compile it. Compiler generates a.class file for us, correct? So this is called as a source code, and this is called as binary or executable, right? Okay. So for example, if you go to Flipkart, you see, thousands of .java files, correct? And do you think complete Flipkart application code will be in one .java file? No, right? Can you write complete Flipkart application code in a single Java file? No. If you write, it becomes, GBs of size. You cannot even open the file. And then there are a lot of, other programming principles which you cannot implement. And, readability, maintenance will be an issue there. So we don't write a complete Java application code in a single file. Instead, it will become millions of lines if you write everything in one .java files. Instead, if you go to Flipkart, you see something called modules. What's that? Module. For example, login module is here, search module, cart, payment gateway, database, and so on. For example, this is your login module. Means they store login functionality related Java files in this folder. Say assume that you have 100 .java files here. Then they store separate, they store search related Java code in a separate folder. This is your cart functionality Java code. When somebody adds item to the cart, right, and it has to forward those items to the payment gateway, right, for processing the payments, correct? Things like that. So there is a some code for cart functionality, and then there is some code for payment gateway functionality. So this is how they categorize the code based on the functionality. So login folder has only login code. Search has only search code, cart, payment gateway, and so on. That's how they organize the application code. Clear with this? With that, come here. For example, developer writes login.java. Login.java. There is one file, say for example. There is one file. One second. You compile this login.java. What file we get? Can somebody tell me? If you compile login.java, what we get?
Dot class.
Login.class. Login.class. Correct? Okay. Similarly, if you go to this login module, there are hundreds of .java files, correct? There are hundreds of .java files, right? There are a lot of .java files here. So we have to compile all login module code, correct? So you have 100 files here. So you compile 100 files. When you compile 100 files, what do you get? You get 100 class files, correct? So you get 100 class files. Very simple. So you have, say, 1000 .java files in login folder. You compile all these 1000.java files, you get 1000 class files. Simple, we know that. You know what do we do after this? Once compilation is done, we create something called package. So we compress, we bundle all these hundred thousands of class fields. We create something called a jar file. Remember this? What is it? Jar file. Jar means Java archive. Try to remember this. You know what is .java? What is there in the class? What is jar file? Jar file is nothing but a zip file. It's a zip. Like, say you have 100, class files here. You just right click and then say create zip. You'll create a zip file, right? It is like login.zip file. If you extract this zip file, what you'll get? You'll get hundreds of class files. So it's not a zip. It's called as a jar, Java archive. Since it contains Java code, we call it as Java archive. It's not a general purpose archive like a zip file. In zip, you can store anything, correct? In jar, we store only Java code. Okay. So this is how we perform the build in real time. It's not about only compiling the code. So we compile all these .java files, we create multiple class files, we combine all these class files, and then we create something called a jar file. It's called the package, correct? A pack of class files, package. Jar is called the package. Similarly, you have search related .java files. You have cart related .java files, correct? Assume that you have search.java, something like this, okay? Search.java. Along with that, you have a lot of search related things. Here also you have say cart.java and then say 100 cart. So what we do? We also compile this particular folder and then we'll get search.class. Along with search.class, we get multiple, class files. And then we combine all these search related class files and then we create something called, we create a single file called search.jar. Similarly, you have a lot of class files and then we create cart.jar, right? Cart.class file. So 100 .java files you have. So very simple. It is .java, then comes .class. You combine multiple class files, create a single jar. You see here, again, you got multiple jar files, correct? Say there's a payment gateway.jar also here. Similarly, you get, tens, hundreds of jar files. You know what? Again, we combine all these jar files and create a single file called var file. Var. Let's call it as flipkart.var. Var means web archive. Again, it's like a zip file. Var is again again it's a zip file. And what is there in the jar file? What is there in the var file? Multiple jar files. Web archive. Similarly, we get, okay, sorry. So we have a lot of .java files. We combine all .java files, we generate the class file, we generate individual, right, jar files, and then we combine all these jar files and then create a single file called var. So this is the final file that we generate during the build. So that's what the meaning of var file. Dev team, git, this is where you clone the code. And here, as we know, this is the jar file, correct? This is the var file, right? Now you understand what is there inside this var file. So this is your Flipkart.var file. So very simple. First we clone. First step. Any project you take, this is what you do. Then you build. Building means what? Now you understand? The build means what is the end goal of build? Creating this particular var file. Second step. And then third step, we build. Third step, we deploy the var file. So into Tomcat server. Now you understand what is there in this particular var file. A lot of class files. That means a lot of jar files, correct? Jar files. Inside the jar files, you have the class files. So when it's a build, right? This is what we do. Build. Building means what? Compiling the Java code. Also creating the jar and then var packages. This is also a package, okay? Var is also a package. It's also like a zip, right? So that is the end goal of build. So basically what we do here, if you go to Git, we have our application source code here, correct? Application source code. So as we know, we cannot directly execute the source files. That's then what we do. We clone this code, source code, right? .java files. There may be some, .java files. There will be some HTML, CSS, JavaScript, and so on. Correct. So what we do, we clone everything and then we build. Building in the sense, we compile the code, we create the jar files. Finally, we create the var file. So var is the final goal of build. So you call var as a package. Okay. You also call this var as artifact. What do you call this? Artifact. Artifact means file which is generated during the build. Okay. What do you call this? Artifact. You can also call, class file as artifact because that is generated from .java. You can also say jar as an artifact because jar is created during the build from the class files. You can also call var file as an artifact. So var is the final artifact that we create. Understand the goal of build? Any questions you have so far? Now you tell me, is it possible for us to, do all these things manually when we have thousands of .java files? No, right? First of all, compiling all these thousands of .java files is very difficult. Again, you have to create the jar files, which contains only login class files. You have to create search.jar, which creates only which contains only the search, and so on. Again, you have to combine all these .jar files and then create a single var file. See how difficult it is for you to do all these things manually. Is it possible for us to do all these things manually, especially when you have thousands of lines or thousands of .java files? Very difficult. So that's where we think about a tool that is Maven. So what is Maven? Maven is called as a build tool. It builds binaries. What is a binary? End binary var file. And why we need a build tool? Because handling this build process end to end is very difficult. It's time-taking process. So we need a build tool that is Maven. So we have .java. You compile .java. You get class file. You combine all the class files, create a single jar file. Again, you get multiple jar files, create a var file. For example, flipkart.var. Try to remember this sequence. So var is collection of jar files. Jar is collection of class files. Correct. Class file is binary equivalent of .java. So developers' job is writing the code. As a DevOps engineer, right? We use Maven. Using Maven, we build application source code, and then we generate the binaries. If you have this binary, you can launch the application. If you don't do the build process, can end user access the application? No. So you have to build. This is your deployment. Got the clarity? Any questions you have in this? Okay. So this is your end-to-end build and deployment process, right? For example, this guy, this is a mission. In this mission, we have a Tomcat server. This mission name is what? www.flipkart.com. Okay. And then users type this flipkart.com and then they access the application. Okay. Right. What environment? What is the name of this environment? What do you call this environment? What do you call this environment? Can somebody tell me? What do you call this environment?
Production environment.
We call it as a production environment because it's a flipkart.com, right? Real users are using this environment. We call it as a prod or production. So once we build the code, see, every day these developers will be modifying the code for bug fixes and then feature development. Do we deploy the code directly to the production without testing every day? No, right? So instead, what we do every day, right? We clone the code, we build the code, and then we deploy this particular warfel into a test server. Remember, flipkart-test.com. That's the name of this environment. This is your warfare. We don't deploy the code directly to the production every day. And then comes developers are developing the code. Every day they develop the new code. Every day, in fact, multiple times a day. In fact, multiple times a day, we have to build and deploy the code, correct? Very simple, remember this. The moment developers commit some code, they need a build. They need a build and deployment. Otherwise, testers cannot test it, correct? The moment they submit some new feature, the moment something is ready, they send you an email saying, DevOps engineer, please take the code, build the code, and then deploy the code for me so that they can test it. So in fact, we will be running this build and deployment. We'll be performing build and deployment multiple times a day. So this is your testing team. They access the application using flipkart-test.com. And then they access the new code. Can somebody tell me which one has the latest code? Test environment or production? Which one has the latest code?
Test.
Test environment, obviously, correct? Because ongoing development, new activities, code will be here. So we work like this for a month or 2 months. And then once a testing team say that there are no issues, one day we build the code and then we deploy the code to the production. You call this as major release. And then this code is tested, right? Every day we deployed here and then we tested it. So now you can safely deploy the code to the production. So we call that as a main release. In fact, in real time, we'll be having multiple testing teams, not just one team, one person. We'll be having multiple testing teams. For example, these people are 10 people, 10 members team. They do manual testing and automation testing. They do manual testing and then automation testing. For them, we create a separate environment. For them, we create a separate environment. So this is your Flipkart event test.com. This is where they do manual testing and automation testing. Assume that you have another testing team. You have another testing team, 10 members team. Okay. So they are working on, say, for example, performance testing. What do? We go and then create another environment for them. Environment means just take a mission, deploy the var file in that, and then install Tomcat server. Tomcat server. So these are like dummy servers, test servers. And name of this particular mission is Flipkart-performance.com. So these people take Flipkart-performance.com, they come here. So these 10 members are accessing the application from this mission and they are doing their testing. These 10 members are accessing the application from this environment, from this mission. They launch the application in the browser and then they do their testing. Why we need to have multiple environments? Because many people cannot work in the same environment. Because, for example, no, these guys are doing some, say, manual testing, right? If other person comes to this particular environment and then restarts the mission for some automation testing, what will happen? This guy cannot work, right? So one person is restarting something, one person is accessing something. So many people cannot work on the same environment. So in real time, you see multiple environments. In fact, 4, 5, 6 environments you see. So as a DevOps engineer, every day we build the application. Remember this. And then we have to deploy the code into multiple environments. Test.com, Flipkart, SIT.com, for example, performance.com, and then UAT.com. You may be having multiple environments for multiple testing teams. So it is DevOps engineer who deploys the code to all these environments. This is one of the major responsibilities that we handle in real time. And then remember, this is production, right? Just before the production, just above the production, there will be one more environment. Remember this. There will be one more environment. We call this as what? Can somebody tell me? Just before production or above production, mandatorily, there should be one environment. What do you call that environment?
UAT.
No.
Pre-prod.
What's that?
Pre-prod.
Pre-prod, yeah. Usually that is a pre-prod or stage. Staging environment, or we call it as pre-prod. Yes, UAT also will be there. So SAT, UAT, maybe, a lot of other environments. So one environment will be there before production, that is called as pre-prod or stage. So think like this. We first, write the code, right? And then we deploy the code to Flipkart-test.com. We do manual testing, automation testing. These people are doing performance testing, SIT, UAT, blah, 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 and so on. And finally, say first we do this testing, probably this testing are in parallel. Before we move the code to the production, we have to deploy the var file to this stage. Because here you might be testing the application with some dummy data, correct? So for example, you are accessing application from Flipkart-test.com, right? You want to test the payment gateway. For testing payment gateway, you need to have a credit card, correct? So here you may be using some dummy credit card. Say you are using 16-digit dummy credit card. With 16-digit card number, you are able to place the order. What if your production has a 14-digit card number? That means these guys are real users, right? You understand this or not? Real users. So real users may be using different data inputs, different data. So it's not about just the data or inputs, right? this real environment, production environment, may be having different configurations. So what we do is, see, end of the day, our goal is to deploy the code to the production in a stable way. That's our goal, right? So what we are doing in stage, right? Usually what we do, we deploy the code, and then staging usually will be having exact configurations that production has. This will be having same setup, same configurations, same things like production, data and things like that. And if everything is working fine here, means it works in production. That is the assumption. So here we do some testing, here we do some testing, right? And here also we do some testing with production data. And if things are working in pre-prod stage, means it works in production. So that's the confirmation. And then we finally deploy the code to the production. So we'll be having multiple environments in real time. Understand this? Any questions you have? Any questions?
Like, what does the final product called?
Means, can you rephrase your question? Final product.
Yes, like you mentioned, it's a staging or a pre-prod, right? So will it be, we should call it post-prod, right?
Pre-prod and then prod. That's all. There is no post-prod. Pre-prod, prod. This is prod. Before prod, it is pre. That's all.
Okay.
So there is nothing called post-prod. It's a pre-prod, prod. Okay. So in real time, there will be multiple test environments. These are all test environments. This is production environment. How many test environments you see usually? Depends on the project, depends on the company. Okay. When you join in real time, somebody will come and tell you saying, okay, we have Flipkart F1 test.com, we have Flipkart F1 performance.com. Staging is almost mandatory. And things like that. So what are different test environments that can exist in real time? Or what different testings we do in real time? So for manual testing, there is separate environment. For performance testing team, there is separate environment. What are the different testings we do? For UAT, separate environment. For SIT, separate environment. So what are different possible testing methodologies that we follow in real time? See this. You all know people first mostly do manual testing, correct? Manual testing means you access the application physically in your browser and manually you test things. For example, manually you enter the username, password, click on reset password, and then you check, you test whether you're generating the password and things like that. Manual testing. There's something called automation testing. Automation testing. Like using Maven, we are compiling thousands of .java files, right? This is the tool for compiling thousands of .java files. Similarly, in testing also, they have some tools. Instead of you manually, test each and every scenario, they use some automation testing tools. Like there is something called QTP, right? Selenium and so on. So using those tools, they perform testing, and that is called as automation testing. Then usually we do something called system integration testing. System integration testing, or we call it as SIT. SIT. Okay. System integration testing. What is this system integration testing? Say, for example, this is your Flipkart, right? You have login, search, cart, payment gateway, and so on. So what we do usually is, first we test only the login functionality. First we test only login functionality. And we make sure that the login functionality is working fine. That means you focus only on login, right? Username, you enter, special characters, username which contains special characters, which should throw the error, right? Name cannot have special characters, right? A lot of scenarios, all the scenarios we test. Then some teams work only on testing card functionality. Some teams work only on, say, search functionality, payment gateway functionality. So we call this as module level testing. Module level testing. This is one module, one functionality. This is another module, search module, payment gateway, and so on. So once we make sure that individual modules are working fine, then we combine all these modules and then we test the complete application as a whole system. Combining all this means, for example, I first log in. Then login should work fine for me. Correct? Understand, right? Login is working fine. Cart, search, payment gateway is working fine. Assume that. Okay. Now I'm combining. So I log in. After login, I do my search. Then I go and then select some items and then add items to the cart. And then I go to the payment gateway and then I place the order. So this end-to-end flow should work fine for me. Possibly this may happen, right? Login is successful. You search the items, you added items to the cart, but when you go to the payment gateway, there are no items in the cart. Possible, right? See, cart as independent functionality is working fine, but if you go to the payment gateway from cart, right? In payment gateway, it is not showing the items. Possible. Correct. So once you search, once you add items to the cart, your login is not working. Possible, right? Because it's a integration testing. So individual modules may work fine, but when you combine the same modules, things may not work. So we call this as integration testing, system integration testing. In system integration testing, what we do, we integrate all the modules and then we see if your application is working as a whole. System integration testing. So there is a separate team for this. They're experts in automation testing. They're experts in integration testing. Similarly, there is something called regression testing. Regression testing team. Can somebody tell me what is this regression testing? What is regression testing?
Recursive. Recursion
Recursion.
means repetitive.
Okay, see this. There is a login, for example. Okay, login, module code, search is there, cart is there. Okay, and here you have your database code, DB. Login connects to the database. Okay, for fetching the username and passwords. When you search will go to the database. It will search items. You have all items in the database. So you add items to the cart, right? 10 items I added to the cart. So it will remember those 10 items by storing them in the database. Login, search, cart, and a lot of other modules are using database. Assume you are introducing or developing some new feature in your login. Say, for example, you are introducing a new feature in your login. For example, earlier, mobile login option was not there for your users. You implemented mobile login. Okay, you can log in with your mobile number, assume. So in order to implement this particular feature, you would have modified something in database, correct? Understand? Login uses the database. So in order to implement that mobile login, sometimes you would have modified database code. Assume that there is a change in the database. There is a change in the database. What is that feature which we are developing? What is that feature we are delivering to the user? Login. So usually we have to obviously test this login. Do we also need to test this? Do we also need to test this and then this? Can somebody tell me? Okay, fine. One second. So you modified some login functionality code, right? And then you also modified database code. Okay. So there is a change here. Anyway, you test it. There is a change here. Anyway, you test it. Do you also need to test search and then cart? Can somebody tell me? Obviously, I do. I test this. I test this.
Yes.
Yes, correct. Why? See, what matters to, where you modified the code, login functionality code, database code. Ideally, you can search, you can test this and this, because see, there is change means it's prone for errors. So usually we go on and test it. But it's not, just login and database. You also have to test search and cart functionality. Why? Because search is using database, cart is using database, correct? So this change impacts or may impact on search and cart functionality also. So you have to test this and this. See the dependency now, right? These two things we modified. And then when you modify this, you also have to test some other dependencies. We call that as regression testing. So there'll be a separate team, right? They are experts, right? If there is a change in login, if there is a change in database means they know what other things use that and then what other things need to be tested. So regression in simple sentence means test the new functionality as well as the other functionalities which depend on this, which depend on that. Regression testing. Want to ask ChatGPT can give me few new words. What is regression testing? Okay, see this. Regression testing is type of a software testing that ensures that recent code changes have not negatively impacted the existing functionality. Recent code changes have not negatively impacted on the existing functionality, correct? If you modify this and this, so it may negatively impact on this and this also, correct? That it ensures that recent code changes have not negatively impacted on the existing functionality of the software. The goal is to verify the new modifications, correct? Login, whether it can be bug fix or whatever it is. The goal is to verify the new modifications, right? That the new modifications have not introduced new defects or broken existing feature. It's the same thing, correct? So if this is not working, that means you are introducing a new one, right? You are developing something, you are breaking something, correct? So that is the goal of regression testing. Clear about regression testing? Any questions you have about this? Why am I explaining all these things? You are a DevOps engineer. But this is a testing, test related topic. So I know that fact. So the thing here is, as a DevOps engineers, we will be every day closely working with the development teams, working with testing teams. Developer modifies something, right? Ask for the build. So there's some compilation error. We will be working with the person. Developer modifies 10 files. 10 files are here, 10 files, 10 files. But somehow these 10 files are not copied in the environment. If the code is not there here, people cannot access its functionality, correct? Developer comes to you, why my code is not deployed, right? According to the situation, we work with the developer. You deployed the code to, test.com, but these people are unable to access the application, right? They're unable to see the flipkart.com in the browser. They come to you, hello, DevOps engineer, I am unable to access the application, right? And it is impacting my testing timelines. I have to complete something by, end of the day today, right? Please go and then bring this environment up and running for us as soon as possible. Correct. Similarly, we'll be interacting with other testing teams also. Suddenly this person comes and says, I am unable to do regression testing. I am unable to do unit testing. I am unable to do integration testing. So you hear all these words in real time. Okay. That is the reason I'm explaining this. See, you are not going to do any testing. Okay. My intention here is to make you work comfortably with the other team members. You cannot ask them, okay, what is regression testing? What is this integration testing? You can, but they think that, right, you don't know even ABCs of testing. So it's good to know concept. So this is where this matters a lot. As I said, always say, you find the course in YouTube, complete course, but this is, nobody teaches this mostly, correct? So this is the real time. So even you join in real time with 3-4 years experience, you can comfortably work with those team members if you know all these things. So I'm preparing you with all these things because I know you will face all these things in real time for sure. Understand what is manual testing, automation testing, integration testing, regression testing. Similarly, there is another testing type called, say, UAT. UAT, user acceptance testing. User acceptance testing. This is a kind of testing, right, where you perform testing with some real-time data. Okay. I want to ask UAT if it explains the thing in a different way. What is UAT? Stands for user acceptance testing. Okay. See this, user acceptance testing, correct? Okay, now can someone tell me what is UAT? What is UAT? Give me some example for this. You know what is this? Explains what is UAT. Give me some examples for that.
So, user friendly testing, like it's compatible to user to use it in the daily life. Like suppose in the Flipkart, whenever you log in, like he or she should not face any kind of much challenges.
Yes, it is. So for example, you have tested, you have done manual testing, automation testing, regression testing, right? And now everything. Okay. But again, you are performing the testing here with your data, correct? With your data. Your, with your assumptions, 16-digit credit card and things like that. So testing is fine. You have not found any issues. Again, to make sure that application works, software always works. What we do before we deploy the code to the production, we release that code to real users. You have a client, say for example, some client. Okay, so you have 10 clients, 10 software companies. You have 10 software companies using your software. Okay, client 1, client 2, 10. So what you do, before you release the code, your software to all users, you give your software to a specific client who probably may want to test or explore the cutting edge, latest version of your software. So that means what? These people, right? You release your software to only a few people, a few set of people, or one client or two client, and then they use your software in real time. That means impact is this. If something major is not working, it is happening with only a few set of users, right? Or one or two clients, right? It's not impacting whole world, correct? So we call this as a user acceptance testing. That means you have put great efforts, you tried your best to find the issues, but real time is real time, testing is testing, right? So here again, what you're doing, you are again testing your software with a real client in a real time environment. We call it as user acceptance testing. Sometimes you would have observed this in Facebook, right? So assume that Facebook is bringing some change. They are for example introducing some new emoticons, or they are removing few new emoticons, for example. Sometimes if they feel that it's the change is very sensitive, they won't release it to the whole world, because what if people don't like something, right? So what do? They release that feature to only few set of people, maybe one region, only India, or only to Android people, or only to Apple users and things like that. Why? So they release to few set of audiences, and then they check the feedback. They check the feedback. So the strategy people follow in business, right? And they analyze, they see a lot of data, right? They analyze the customer behavior, right? And data, and they do a lot of analytics there, and then they see whether that is impacting, or whether that change is engaging the users, or it is discouraging users to use the platform, or things like that. And then they release the code to the customers. Probably you can also think that as a user UAT. For example, YouTube, I think 2 years back, I guess, disabled the unlike button in YouTube. Earlier there was like, unlike, right? So they disabled unlike now. I mean, recently, I think 1 or 2 years back. So this will ensure that your application works in line with your real time. Second thing, you can also understand the customer behavior. User acceptance testing. You understand, right, how many right? How many steps you are taking before you move your software to the production. You're doing manual testing, you find some issues here. In automation issues, you find some issues. In integration testing, your approach is different, your goal is different, so you find some issues related to integration things. Regression, again, you are testing your software in a different perspective. You find different bugs here. In UAT also, you may find some bugs, correct? This guy will say, okay, this is not working for us. And another important testing that we do is performance testing. What is performance testing? Can somebody comment on this? Performance testing. What is performance testing? You test the performance of your system.
Application.
Yeah. You also call it as load testing, load, or stress testing, or performance testing. That means, see, during Big Billion Days, for example, or Amazon Great India Festival sales, you get a lot of users, correct? So assume that with 10,000 users, right, login, 10,000 users at any point of time, your application works fine. What if suddenly 20,000 users login because of some discounts or some seasonal sales you are performing or some things like that, and suddenly 20,000 users or million users come. So no matter how many users come, right, to your platform software, you should be able to serve your application without any latency, right? With the same speed you have to serve. So before you release your code to the production, right, people also do performance testing. Then probably UAT is last, okay? After performance testing, you go to UAT. And then it is a pre-prod. You deploy your application to the pre-prod, you do some testing there, and then finally you deploy your code to the production. So these are different test environments that you see in real time. Test methodologies or environments. Forget of this. What is important is test environments. So in real time, you may see these different environments. One is for manual automation testing team. One is for UAT team. One environment is for SIT. One for performance testing. One for pre-prod. One for prod, and so on. So you may be having multiple environments in real time. And as a DevOps engineer, we take care of all these deployments. And it depends on the application, okay? It's not that all applications will have all these environments, right? So it's not mandatory. Some companies don't do performance testing. They say, we have very less user base, very less business. We are at, we don't have much traction in the business. We are at a early stage now. We don't need performance testing, right? Probably we don't have many clients. Our application is not very sensitive. We don't need UAT. So when you join in real time, somebody will explain what kind of test environments they have, and your job is to deploy all those environments. We deploy the code to all these environments. Now you see the responsibility of DevOps engineer. It is DevOps engineer, right, who enables testing team to do their work, correct? If you don't build and deploy the code in these multiple environments, they cannot access the application, right? So Q teams are depending on you. Developers are depending on you. Development teams also, right? If developer job is developing the code, once development is done, they delegate their code to, they give that code to testers, correct? So it's also developer's responsibility to get their changes tested, correct? So developer comes to you, hello DevOps, I have pushed some code, please deploy it quickly so that testing team can test and confirm if my changes are working fine or not. So we help development teams and then testers in getting their things done. So developers, testers. In between comes DevOps, correct? They write the code. Then second step, we come in the middle, we build and deploy. Then only these people can test the code. So we are actually connecting development teams and then testing teams with our automation. So these are the different application environments that you see. Environments, test environments, application environments. There may be something called dev environment also. Okay. Dev environment is only for the developers. Developers also do some testing, the basic level of testing. So we give a separate environment for them. Test environment. Then comes what? System configuration. System integration. Testing environment. Correct. Then regression environment. Performance environment. UAT. User acceptance environment. Then comes pre-prod or stays. Then we have
So that is user acceptance testing.
user acceptance testing. That's correct. So dev environment, test environment, SIT environment, regression environment, performance, UAT, pre-prod or stays, then production environment. Understand about this is just for your information. Okay, see, it is my wish, right? It's my choice. Probably if some other trainer is teaching DevOps, they may not include this topic. Okay, because this is not related to DevOps. So it's always trainer's choice. So I feel that this is very much important for you, to work in real time. So no need to read much about this. If you have, and if you want to spend some time, just go Google or ChatGPT and then try to understand. Okay, so having a bit more knowledge on these things is kind of a plus. So these are the environments we have. That's all. So you know the background now. Okay, how development, testing, build and deployment happens, right? And the role of DevOps engineer in real time. And from tomorrow's class, we will install Maven, then we'll start automating all these things. Again, our job is very less here with respect to Maven. Developers, do a lot of things here. You will understand that later. Okay. And you asked for the roadmap, right? with respect to the tools, probably remind me 5-10 minutes before class ends tomorrow. I'll explain that. That's all from my side today. Any questions?
So like
Lynn,
Maven is used only for Java-based applications, right?
there is a message here to ensure the changes not affecting the existing code. Then yeah, I think you're talking about the regression. That's correct. Yeah, go ahead. What's that, Rajesh? Come in.
Like Maven is used for only Java-based application or any other programming languages?
It's only for Java.
Okay.
For C++, there is a tool called Make, M-A-K-E, Make. For .NET code, for compiling .NET, there is a tool called N-Ant or MS Build.
I heard something about like Gradle is, if I'm not wrong.
Gradle is also for Java.
Okay.
So for Java, we have Ant, Maven, Gradle. For C or C++ code, that means if you want to compile C, C++ code, there is a tool called Make. For Java, Maven is very popular. For .NET code, if you want to, if you want to compile .NET code, there is a tool called MS Build. MS Build. So Gradle is also good. It's these two are advanced, but Gradle is more kind of a scripting. You need to know, a groovy programming narrative. So that's the reason people mostly don't prefer it. So Maven is preferred one in Java. This is very old tool. People don't use it these days. In C++, this is the only tool you have. .NET, this is the power. So we are learning this. Mostly it's a Java world. 90% of the cases you will work with, Java-based applications only. And if you know one programming, so one build tool, working with another tools is very easy, first thing. And as I said before, right, most of the build automation things will be done by developers only. So usually we'll just go on them, execute some command, and then that will build the application. You'll understand that later. Okay, Rajesh, MS Build, Make.
Yes, right.
Any other questions? Thank you.